Hi class, we're looking at reviewing 1.3. This is the raising money problem, okay? Notice my table. I have Alana that's starting out at $5, okay? She's getting $5 for whether she walks anywhere or not. And then she's earning 50 cents for each lap, okay? Gilberto doesn't get any money if he doesn't show up and walk, but he's earning $2 a lap. And Leanne gets $10 if she shows up, but guess what? She is not making any money, so it doesn't pay for her to walk. If you look at this, the independent variable here is the amount of money, and the distance is the dependent variable. Okay? Check out my graph. Notice my little happy face color code. Okay, the stars are going to be Leanne. Notice her line is flat. Alana starts out at 5 and moves up, and then Gilberto starts at 0 and moves up pretty quickly. Okay, notice my distance here. My money's on the y-axis. That's question A1 and A2. Moving on to A3. A3 asks us to write an equation for each pledge plan and explain what information each number and variable in your equation represents. I'm using M for money earned and D for the distance traveled in kilometers, okay? So if you look at Leanne here, hers is the easiest equation to write because no matter what distance she walks, she gets $10, okay? And if you want to think about that as you're taking 0 and multiplying it by her distance, and it's always going to give you 0, and then adding $10 to it. With Gilberto, he's earning $2 for every lap. And notice with Alana, she's earning 50 cents, 0.5, for every lap, but she also gets this added $5. So we ask ourselves, what pattern of change for each pledge plan do you observe in the table? Well, with the table, the pattern in the table is they go up by a constant rate or linear. Notice with Leanne, she doesn't change, so hers is constantly not changing. But with Gilberto, his is going up by $2, and then Alana is going up by 50 cents. In the graphs are also linear, with the steepest one being the one with the highest rate, despite where they start. So if you look at Gilberto, his is the steepest line. It's going up pretty fast, whereas Leanne is completely flat, and Alana's in between. If you look at the equation, the pattern is apparent in the equation as it is the number directly in front of the D. So we notice there's no change in Alana's graph, or excuse me, Leanne's graph. That 0D is really important. With Gilberto, notice his graph is going up by 2, his table's going up by 2, and notice the 2 in the coefficient of D, which is 2, and then, of course, Alana with the 50 cents. Question B asks, suppose each student walked 8 kilometers. How much money does each sponsor owe? Well, Leanne's going to always owe 10. Gilberto's is going to be 2 times that 8, which is the 16. And then Alana is going to be 50 cents times the 8, which gives you the $4, and then you add the 5 for a total of 9. In B2, suppose each student received $10. How far would they have to walk to earn $10? Well, Leanne doesn't have to walk anything because she's getting $10 no matter what. But in order for Gilberto to earn $10, he has to walk 5 kilometers. Okay, he's walking those 5 kilometers so that he can earn $10. And poor Alana, she has to walk 10 kilometers in order to earn her $10. She's only getting 50 cents for every lap. Okay, she's only getting 50 cents for every lap, and she gets the $5 to start with. Okay, moving on to question 3 in problem B. Question 3 asks us, on which graph does the point 12, 11 lie? What information does the point represent? Well, if you go back to your graph here and look and see, 12 would be the number of laps walked, and here's 5, 6, 7, 8, 9, 10. So we're looking at somebody whose graph's over here and up about right here, okay? And if you can kind of imagine whose graph's going to hit that mark right about here, Okay, whose graph's going to hit that mark? If you look at it, it's going to be Alana. So Alana's, that is on her graph. That point is on her graph. Okay, you can also use your graphing calculator and enter her equation and look at the table and see that 12.11 is on there. That means she's walked 12 laps and earned $11. And we can check that because a half, 50 cents times 12 is 6, plus 5 gives us the 11. Moving on to question 4B. Question 4B says, in Alana's plan, how is the fixed $5 donation represented in the table? Well, you can see in the table that first $5 is where her distance is 0. That $5 in the graph is where the graph crosses the y-axis. That's where it starts. And in the equation, you can see that plus 5 that we didn't have in necessarily Gilberto's. Question C asks us, Gilberto decides to give a t-shirt to each of his sponsors. Each t-shirt costs him $4.75. He plans to pay for this from the money he collects. So here's going to be our equation. Remember, he's making $2 for every lap, but now we have to take away $4.75 from that money. So if he doesn't walk, and notice here's our graph, here's money, here's our distance. With our graph, he's going to start out, if he doesn't walk any laps, he's going to owe $4.75. Notice how it's below this red line here, which is our x-axis. He's going to owe $4.75. So he better start walking, right? If he walks one lap, he'll only $2 minus $4.75. He's going to still be in the hole, $2.75. At 2 laps, he's going to be in the hole for 75 cents. And then finally at 3 laps, he's going to start making some money at $1.25 here. Okay? So think about, this is how much money he's earning for every lap, and this is where he's starting out at, how much money he's actually started with, which is negative $4.75 for each of his sponsors. Okay? So we've graphed the equation for the distances up to 5 kilometers. And if you look at his graph and compare it to the other graph here, none of these graphs start below that y-axis, okay, or that x-axis here. None of these graphs, Gilberto starts at 0, 0 and moves up. But with Gilberto, if he decides to buy t-shirts, he's going to start below the $5 mark, okay? So, and then the line is the same. Gilberto's line here in question part C and in question part 1 is the same line. It's just starting at a different spot. If we moved this line to this graph here, it would follow, it would always trail Gilberto's line here. Okay? Great job, class. I will see you tomorrow.